We are going to talk about magic. So this is everything that's happening today is magic. So it's a fable that we have stickers, by the way. I forgot to say that. So please take a sticker. We have T-shirts. We don't have, unfortunately, we don't have T-shirts for everybody. So we still have to find a way to the first way to distribute them. But yeah, please feel free to take the tickets. I think Sven also has tickets for Babel. So yeah, we are here in this conference. We are all together. Many magic things when happen when you start to contribute to an open source project. But this magic only happens because of collaboration. So I think it's actually open source. Open source is nothing itself, but only because it's a way to collaborate between many people and from different countries. And you are also collaborating with this conference by coming here. So you are making also this possible. You are making the magic possible. And but I've been thinking a lot about these ways of collaboration and how we are doing programmers. Actually, because I haven't been a programmer for a very long time. It's been almost like 5 years, and also it's been open source and contribution at GitHub has been, for me, it's more or less in parallel with a journey to discover programming. So I was very amazed to see all the possibilities that this open. And GitHub, this tool, I think is the only, among others, but mainly GitHub is what we all have in mind. This is very important because this has made the entry barrier very low. So anybody from all over the world, anybody, you can post some code, and then everybody can see it, and everybody can contribute. They can try it out. They can send you their feedback. You can do the same with other projects. So it's something that I think is making the magic happen. But there's one thing that worries me a lot, is that the non-programmers are not invited to the party, because this is only for GitHub. Even if the barrier is very low, you still need a lot of knowledge about programming, a lot of knowledge about source control, how to do programming languages, for example. So I was trying to think how it's possible to invite non-programmer people to this party as well, to this party of collaboration, because they have collaboration in other fields. Of course, I was working in translation, for example, and they have like forums, like something similar, like to Stack Overflow. But it's completely, it cannot be compared to the level of collaboration that you get in the programming world. So I think it's very important, also for us, for programmers, because you see the GitHub projects that they are very endogamic in the sense that they are most of them are about tools that help development, So it's a very close world because there's only programmers there. And sometimes you get projects about sound, about architecture, but most of the times it's somebody that has this knowledge and is also a programmer. But this good is fine. But I think that we need to bring people who have knowledge of other domains, but they don't have knowledge about programmers, but we need them as well, because we have to increase this collaboration to other fields as well. So for example, this project, the Gamma project by Thomas Petschek? It's also done with Fable. I think it's really good because you have some visualization here, but then you can edit these visualizations, and you get this editor. So you can see, and you can modify. So it's a way to mix, to have several levels. To have one level is maybe the normal user who will see the data, the graphic, the interaction, and they can do something with that. Other users that know a bit more, and they can go here. This is kind of, it's not exactly a programming language, but it's something that you get features that we are used to use, like auto-completion, IntelliSense, errors, for example, you see here. So I was very interested by this, that you can reach non-programmer people using something like this. And also I was thinking about languages. One of the good things about the F# that I like from F# is that you can create, it's not only F#, it's most of the ML languages in this family, that you can create specific domains and they can be used to communicate with other people. So for example, this Scott Waslin has this sample that you have a car game, and as you can see here, maybe possibly a non-programmer, maybe it's easy to understand this, so you don't have to explain that much. So they can see they have the suit, and the suit has 4 cases and the rank, and they have a pairs here of suit and rank for the card. They have a list, and then they have a player who's a name and a hand. So basically, I think the knowledge to understand this is not that much, and you can, if you are a programmer, you can use this directly in your code, but also as a way to communicate with other people. There was also a tweet by Matthias Rondevinda that he was talking about his experience with communicating with the client, and he could use directly his model in his program to talk to the client, and then it was possible to catch errors. So this also, I think, is a very great advantage. I'm going to digress here a bit about talking about natural languages, because I'm actually a linguist. This is my degree in the university. So I think about languages sometime. And I was trying to think about the difference between natural languages and programming languages and how can we overcome them. So usually the natural languages, they are divided into two kind of languages. So we have subject, verb, object languages. Usually, for example, English, French, Spanish, Portuguese. That you have the subject first, then you have the verb, and then you have the object. So you have, for example, John eats food, something like that. Very easy. Some languages, they have the verb at the end. So they have the subject, object, and verb. This, for example, in Japanese. German is very interesting because in German, sometimes you have, most of the time you have the subject, verb, object, but for relative clauses, for example, so for secondary clauses, that you have the subordinate clauses, you have the verb at the end. So German is kind of a mixed language. But for programming languages, it's interesting because you have the verb at the beginning. So, for example, you have this a function that is called change extension of the file, and you say this should be actually JS, for example. So you have change extension. This is the verb. File name will be the subject, and the object is usually comes at the end. In F#, we usually do it differently. We do it with the subject at the end, the object, and the verb. And this is because we have the pipe operator, and the pipe operator is very good for chaining things. So that's the reason that mainly, most of the times, the subject comes at the end. But you may think that this is one of the examples that programming languages are very, very separated from natural language. But then, if you think a bit about it, it's not the case, because actually, programming languages are about instructions. So actually, in imperative, in natural language, in the imperative mode, we do have the verb at the beginning. So if you say, kick that ball, Ronaldo. So you have verb, object, and subject. So actually, it makes sense. It makes total sense for a programming language to have this order. So they are not, I think for me, this is a hint that programming language and natural language, they are not that far away. By the way, sometimes the programming language, they do have the subject, object, verb. Actually, no, there's a mistake. Sometimes they have subject, verb, object structure. Do you know when? Yeah, dot notation, that's true. In the object-oriented programming, usually you have the subject, then you have the verb, and then you have the the object. Sorry, this wrong, this slide. But I think this is one of the reasons, because the object-oriented programming, most of the times, when you see the examples at the beginning, they're always comparing the language with real life. So you always have the example of a cat, an animal, the inheritance, something like this. So this, I think this is also one of the reasons that usually at the beginning people find object-oriented programming more like natural, because they may be closer to natural language here. But again, I think it makes sense to have this verb at the beginning, because you are actually making instructions. So we have these programming languages. We have the statements and expressions. And usually this is one of the differences between functional languages and imperative languages, that the imperative language, that most of the times you have expressions and statements, and in the functional programming language you have the expressions. And then you have limited flow control. So you have structures like ifs, like imperative languages, for, while loops, or pattern matching in F# and other languages. And in natural language, actually you only have statements. I don't think that you have anything that returns something. It's something that you say, then it's already said, so it's some information. But you have a much richer flow control. So you have these lots of connectors. So I'm talking and I say, but, however, then, therefore. So all these connectors, they're used to articulate my speech. So I think this is important. I think when I was moving from something like C# to F#, and moving from from statements to expressions, I think this was a click for me, because I like very much the languages. And then this allowed me to articulate my program flow much better. So when, for example, link, I had the same feeling with C# and many people had the same feeling with C# and link, because with link, all of a sudden you can articulate everything much better. You don't have to you don't need these for loops to modify anything. You can just express everything with just like a single sentence, you could say. So I think this the combination, especially the combination between expressions and unlimited flow control, they can give you something closer to the combination of statements and much richer flow control in natural languages. So let's see an example, very, very simple example of this. So again, this is going to be really, really simple. Again, this a way that in F# is very, very useful to create a domain model. In this case, we only have persons, we have foods, and we have drinks. And we can use discriminated unions to represent that. Then we have the verbs. And in the F#, usually, even if you create some side effect, in the F# we know that we just return the subject. So we can change, we can do this speech articulation, we can just keep on the flow of the program. So we have eat, drink here. And then this the usual way that we do in F#. Very simple. Just, you can see it here. So yeah, it's fruit and he drinks wine. Okay. I like that F# is so flexible that even if you want to make it, maybe you can think that this is not very close to a natural language. So, for example, you can make something like this. You can say make somebody, and it's really simple. Just if you want to keep the subject, verb, object structure, you can just create this make helper, and then you can say, okay, let's make Sarah eat fish. In this case, it's more it's clear that you are forcing her, or this an instruction. Okay. I would love that. It would be interesting that you could also have name operators, so it could be possible to do something like this. But unfortunately, it's not. But it will be also very nice that you could say something like make Sarah eat fish and drink water, and this will be compilable code. But still, I think this a way to create something that it's really easy to understand for a non-programmer. So my point here is not that all your programs will look like this. No, probably I don't think that F# or any programming language for that matter. I think it's just readable by nature in the sense that you will understand everything. So this depends a lot of the programmer and many things, but I think this with F# is possible to create these DSLs or create like a subsets of the language that you can use to communicate with other non-programmers. So we could make some kind of program, like making the instructions, like eat fruit, drink wine, and it will be very easy for anybody to understand. But we have a problem. You know what the problem is? The problem is this. It's everything here around. It's this. Problem is output, debug console. It's the ID. So IUNI is the problem. No, IUNI is not the problem itself. The problem is that the non-programmers, they are not going to download everything. They are not going to set up their environment. They are not going to learn how to, I don't know, what does this mean? They don't know what is all of this, right? So we already know because this is our work, and we like these tools, but they don't know. So it's we want somebody to imagine that you need the help of a domain expert on something, or economy, architecture, anything, and you create a subset of the program of the language, so to help him or her to help you to create some of the functions for you, and this is very, very helpful. But they need to install everything on their system, so it's not ideal. And I have some shocking information for you. Is that many people don't know what the Git is. So even and they are still smart. It's not like you don't know Git? It's that you didn't go to school. No, they did go to school, but it's not like for us it's like something so natural. But for many people it's not something they will understand. So we need something that everybody has. And what's something that everybody has nowadays? Yes, a browser. Mm-hmm. And even we don't have Internet Explorer anymore, so it's becoming even much better. So before we had to deal with the people having browsers and the people having Internet Explorer. So nowadays, I think I don't know. I don't use Edge that much, but it's becoming a bit better. So yes, thanks to two mysterious contributors, we have ways to run F# in the browser. So we have these two contributors. We don't know the identity. I think we are very close to know the identity of this one, but I completely lost hope for this one because it's really difficult. As you can see, he's using very advanced techniques to hide the identity. He's using sunglasses. He's using a hat, so it's not possible. And it's possible. Oops, stepping on something. And maybe it's him that he's acting in the background. And I don't know for sure, but it's possible that this is not his actual picture. Okay, and the most important thing that I know for sure that we'll never know who he is that he has an encrypted name. So in Cave, this is very easy to understand, but this, how do you even pronounce that? So, but anyways, thanks to these two mysterious contributors, we have ways to run F# on the browser. We have now the Fable repo. Have you used it? Yes. That's good. I like the spirit. Yeah. Okay. So here the Fable repo. You can run code in your computer. You have shell call, things like this. You have the examples. But would you think this is something easy to use for a non-programmer? We don't have here we don't see the errors until we compile. We don't have auto completion. So even if I created this language subset, it's going to be hard for them to use it. So would it be nice to have some kind of this experience we are having with IONI, with the language subset that the F# allows us to do, but also with this everything in the browser? Do you think it would be nice? So let me present you today Fable IONI. Let's. Run it, and this was working at 3 a.m. in the morning, so hopefully it should be working now. Okay, so we have Fable IONI. Let's make this bigger. Well, sorry for this. Okay, we have auto completion. We have IntelliSense here. Yeah, all the things. We have error checking. So as you can see, if I pass, if I make a spelling mistake, so it's going to tell me. Can you see it? So it's even giving me the suggestion of what I should be using. It's not that complete at the moment. It's only mainly error syntax and auto completion, but there will be more features to come. And this is all happening in the browser, okay? So there's no server here. I can show you the network, so you can believe that I'm not getting, do you see here? There's not getting any network request to do the, if I add new one, then now I get it. Okay, but as you can see here, there's no network request. This is all happening in the browser. So I want to stress this because it means that this not thought to be able to be just a tool to test F# of Fable, which also it will be one of the use cases, and it will be very nice for newcomers that they can test everything very quickly without having to install anything in the system. But I want this to for you when you have something, when you have a web, when you want to show something to the people, and when you want to allow interaction in your web page, and you can create domain-specific language. It doesn't have to be F#. It can be something more restricted, and they can already using the web page, and they don't have to install anything. They don't need plugins. They don't need Silverlight. They don't need anything. Okay, so again, we have something here. Let's cheat a bit. And paste this code here. Actually, I could have, because this is actually Visual Studio Code in the browser. It's a Monaco editor, so you have everything. You have many commands here. You have meme mapping here. So you have everything. This is the Visual Studio Code directly happening in the browser. And then now I can take this code. No, I don't have to highlight it. I'm going to press Alt plus Enter, and this is changing. Okay. Something like this. So yeah, it's my hope is that you can use this for your own projects, and this will be a web component. So it will be something that you can put anywhere. And I'm hoping that this will help a lot to increase this collaboration between programmers and non-programmers. And of course, if you want to somebody else to post results or to share something with anybody, then you'll need a server. But this component, everything that I'm showing here, I was hoping to have some more complex code, but we have to. We only have this at the moment. Sorry, I didn't have much time to prepare. But this everything that's happening here, you can just embed into your web. Not today. We still need to polish it a little bit, but you'll be able to put it everywhere and just run, have auto-completion, error, syntax highlighting, and you can run the code directly into your web page. Here I'm using these React bindings for Fable, so I could change. I think here I can change. I want this to be. If I want this to be red, I'll put it. Then I can run. So this is a bit different. This is here. This Fable, which is actually running in the background and recompiling everything. And this is just okay. Oops. This is just happening directly in the browser. So basically, that was what I wanted to show you today, and I think I'm already done. So if you have any questions, I'll be very happy to take them. If not, we can move on after a break to a Gene's talk. So please, anybody?
Yes, just to ask, did you build the full FS autocomplete in Fable to do that, or is it just a subset?
You have to ask. You have to ask this person. You have to ask this person. I know this this part of F# autocomplete there. Actually, it's not. I just put some kind of F# autocomplete, but it's not F# autocomplete. It's actually the F# compiler who is providing most of the thing. F# autocomplete is just a wrapper to call the F# compiler, but it's just everything is the F# compiler. But I'm afraid I cannot tell you much about that because everything is done by Encave. So he or she, we don't know, is expert in the field. So I tried to invite him, but no, he wanted to remain mysterious. So yeah, but yeah, it's a big part of F# compiler that is being transcribed to JavaScript. So basically, is this if I run it again. So this very big file, I know we have the this 8 megabytes of JavaScript. This is actually a F# compiler and Fable together. So they are compiled. Fable is compiling itself to JavaScript, and they are working in the browser. So Fable is there to compile the F# code to JavaScript, and then you can run it, and F# compiler is there to create the AST and also to give you all these things about IntelliSense and error syntax highlighting, error checking, and such. It's actually this 8 megabytes, but it can be compressed a bit more. For this example, I didn't compress the results. So it's around 6 megabytes with gzip. It can be transferred in 1 megabyte. So yeah, it's heavy, but yeah, at least I think it's bearable with a good connection. And once that you get it and it's cached by the browser, you don't need to download it again. So it's you can just play with it for hours.
I just wanted to ask, which modules can we open inside of the in-browser editor?
So there's something that I still, at the moment, it's only just one single file that you can do. We want to add the feature that you can import libraries and many things, but at the moment, you can only have the things that are compatible with Fable. Basically, what you have here in Fable. So if you go to language compatibility, so basically it's what you have here. So all these APIs from the VCL, .NET Base Class Library, and these APIs from F# Core. And then you can also use you can also use, for example, Fable Core itself, because Fable Core here I'm using this a global function that is actually set up here. Make global. So I'm setting a global function here in the React component, and then I can call this global function from the code in the editor. And this actually in this case is not needed, but this, for example, for to tell Fable that an F# record should be translated as a plain JavaScript object. But yeah. So basically, yeah, there's the things in the .NET BCL and F# Core that are compatible with Fable, plus some of the helpers in Fable Core itself. But we want to this in the roadmap to be able to have multiple files in the editor, and also to be able to import libraries, for example, from probably not from NuGet directly, but maybe we can make a way to also distribute libraries to this kind of editor, online editor. Somebody else? Yeah? Ha ha ha, brothers, yeah. I think you have to ask a man over there that no, it's the history with it's interesting because the Gamma they have type providers, but they're using a different mechanism, so it's not possible. The history with type providers and Fable is a bit complicated. I didn't put much attention, but they were actually compatible. So we were using type providers in Fable, but most of the times the problem was that the type providers were erasing code, were generating code that it was not compatible with Fable. So I/O, network connection, and things like this. We don't support this .NET API. So this was mainly the reason that the type providers weren't useful in Fable. And then we moved to NetCore, and because of NetCore and type providers are not still, I'm not sure at the moment, but there were some problems with NetCore. So that's why I haven't, I didn't check that much, but yeah, it should be in the hopefully in the close future, the near future, they should be compatible with Fable. Why not? Node.js to run this running in the browser. You can do Node.js applications with Fable, but this is running in the browser. So you cannot call Node.js APIs. I don't know. They're like some polyfills for Node.js APIs in the browser. Maybe use them. You can also use them. But so in short, I think also Maxime is going to show us tomorrow probably an Express a Node.js application with Fable. So in short, the answer is that you can use Node applications with you can create Node applications with Fable, but because this is running entirely in the browser, you don't have access to the Node.js APIs unless you polyfill them or something like that. But in principle, this is only for the browser. So this is compiled to JavaScript, and then it's just evaluated. So it's not you have access to what you have access in the browser. Anybody else? So thanks a lot again. Thanks a lot for listening. Thanks a lot for being here. And yeah, I hope that you have a wonderful day.